what is the area under that curve? Okie dokie? Katie? 1/2 b squared. So area of a triangle, this is a triangle, is 1/2. The base is this b. And if you input a b into this function, that's going to be the same output. So that's b. So the area of this is 1/2 b squared. Yes? You guys agree with that? So if you choose some dummy variable b, you go out to some variable b, the area under the curve, the exact area under that curve, under the x function, is going to be 1/2 b squared. Now, Sandy, what if I went out some x? What if I just called this x? X. What would this area be? Does everyone agree with that? So the area under the x curve up to some x is 1/2 x squared. The area under this curve, this function x, out to some variable x, is 1/2 x squared. Draw a picture. Tell me that area under the curve. The area under the x function out to some x, 1/2 x squared. So it's going to be steeper. The 4x function. Again, draw a picture. What is the width? What's the height? Should be another triangle because it goes through the origin 0, 0. And what's the area in this function?
2b squared.
2b. So okay, so it's 1/2 times the base times the height. So that's equal to 2b squared. Yes? If, Brandon, I went out instead of some b, let's just call it x just to keep the same variable. If I went out to some x, so I'm changing the problem. We got the answer to this one. I just want to change it up a little bit. If I go out to some x, what is the area under the 4x function? I went out to some b, and it was 2b squared. Well, instead of b, I called it x.
2x squared.
Okay? Yeah, out to some x. Going to be the same thing. It would be 1/2 x times 4 times the x value. So, okay, so the area under the curve, out to some x, under the 4x function, is 2x squared. The area under the 4x curve, out to some x. You pick the x later. You tell me what the x is, and I'll just plug it into my equation. You tell me how far you want to go out into the 4x function from 0 to a number. You tell me how far, and I'll calculate the exact area under the curve by plugging it into my little thing, an equation I just created, 2x squared. The area under the 4x function is 2x squared. The area under the x function is 1/2 x squared. The area under the x function is 1/2 x squared. Pattern maybe. And we'll leave it there for now. Let's get back to the test, huh? All right. And like, shoot, what did I miss? That one specific thing. How did I go around this specific problem? Because right now, it's probably just a small thing. Okay? So go through specifically. What did I miss? What little idea do I need to tweak? Or anything. So how can we assume all of this stuff? And actually, in this case, you can't. Can anyone tell me why? It's a polynomial of degree
greater than 2.
That means it's at least an x cubed. Does that make sense?
No, it's saying it's greater, so yeah,
what's that?
Got it.
So that right there tells you it's twice differentiable, which is interesting because usually they'll tell you that, and this time they didn't. But that idea of a polynomial function, meaning a line, a quadratic, a cubic, a quartic, all of those are continuous differentiable functions everywhere. It's just if you run out of, if it's a line, the second derivative equals 0, so you ran out, you know? But if the degree is greater than 2, that's at least an x cubed of any shape. You know, big humps, little humps, something like that. Okay, great question. And both were listed separately. And I was like, what the heck? But in the definition of MBT, it says there exists a point C on the open interval, and that one of the points was on the endpoint, the closed interval. So tricky. That's why I'm like, nah, it's rude, you know? But I'm going to tell you guys now, so another subtle difference. Like I said, a lot of these things very subtle. Again, what is an inflection point? Is it second derivative equals 0? Well, it could be different than that. You know, these subtle differences between are we going to go for the trick? We know the ideas, now we got to get all these subtle tricks down. So something to keep in mind that I saw, that MBT idea and the IBT, like there is that point C on the open interval, meaning somewhere in between. And those jerks put 2 of the answers, one of them's on the endpoint. Isn't it rude? Anyway, so that's why I chose that one. So the trick with that one is you have to understand the polynomial idea. Okay. So give yourself another like 5 minutes. I'm going to do a couple more problems. But help each other out. Even the ones that you guys may have guessed on. Sorry to interrupt, Rob. Also, you guys, come after school. Come before school. Let's check a couple of these. Again, we're all getting ideas. And I was just thinking about this over the weekend. How I think I can only compare with last year because it was the only other year we offered AB. But you guys are really overall just like crushing it compared to last year. Just really getting the ideas down. You guys are working hard. So kudos to you guys. You know, and I think you need to hear that every once in a while. Right. Okay. So keep it up. Together in a group, I want us to work on 7. I'm sorry, 7 in the homework. You didn't want to work? Is that a one week?
We didn't do 7.
Yeah, we did not do 7. I want us to do it together. 3 ways. Graph it by hand, on the calculator grapher, or on the solver screen. All 3 ways. Practice it in the group. Okay, number 7. Let's start out there. And again, you should be just getting efficient so that for our quizzes this Wednesday and Thursday on 5.1 tomorrow, and then probably 5.2 on Thursday, if I throw you calculator or non-calculator, it's not an issue. Okay? We're going to finish up with 5.2, and then we're going to talk about that Tuesday, Wednesday, and then Thursday, Friday, Monday, we are going to review for the final. We're going to do a chapter 2, then chapter 3, then chapter 4 day.
Sorry.
Okay, okay?
Yeah.